Today we're going to be working on my folder prototype and my prototyping process. Today I'm going to be skipping over the design process and skip straight to the prototyping and machining because designing is kind of a whole thing of its own and probably warrants its own entire video. To start in the prototyping process, I went ahead and 3D printed it. 3D printing and prototyping is super helpful because it allows you to make quick and dirty prototypes relatively quickly. The print time on this entire knife was something like 2 hours, and so it's a really fast way to get something from the computer into your hands, and so you know what you want to change roughly before you start machining it, and it can save you a lot of machine time and material cost. Here you can see the parts I'll need to machine, my two liners, which will be steel and go over whatever the scales end up being. The reason I'm going with this design is because I can make the scales out of any material that I want to, and so it's very open in what I can use. Now this is the blade, it's skeletonized for making 3D printing faster, and you can also see some of the hardware and bearings that are used for the knife. To start with, I'm going to be making the scales out of G10. G10 is an epoxy sort of plastic material with light layers, and it comes in many different colors and sizes, and it's just an overall very good material to make things out of. Here you can see we're starting the machine process, and machining G10 is super fast because it's basically machining plastic. Here you can see what the scale looks like after the first operation. I cut out all the important holes as well as outlining the scale. And now we go in and we do the second scale. This scale is basically the same machining process, but some different geometry, and it's a mirrored scale. And here you can see what both of them look like cut out. There's some weird machining issues with these scales, but they're just a prototype, so I'll figure that out in the actual units or future prototypes. Then I start machining the second operation, which is going to do all the finishing work on the scale and cut it mostly out, as well as creating the chamfers that you saw in the 3D CAD. Here you can see what the scale looks like with all the contours and stuff. It looks a little weird with the facing operations because I did it differently, but I will be fixing that in future operations. I'm also not a huge fan of how this specific G10 looks, but I will be changing that a bit later in the video. I ended up prototyping this because I don't like how it looks. I'm okay throwing it away once it's done. And so at the end of the video, you'll see some solid black G10 that is machined and how that looks on the knife. So now you can see a better up close of the scales and how the contouring went and stuff like that. These whole scales take about 15 minutes to machine for both operations, so it's super fast because it's a pretty soft material. I then have to cut out the scales. It's pretty standard. I do this in a lot of things, and for prototyping, this is the easiest way to do things. I then start machining the liners, which is a pretty simple operation. I start by drilling the holes that I need and then cutting out the geometry. It's a 1/16 of an inch thick, so it's pretty fast, and I'm making this out of AEB-L steel. Here you can see what the liner looks like once it's been cut out. It's pretty clean, but there's definitely some work to do on this program. And then get right into the next scale, which is skeletonized and has a longer runtime. So go ahead and enjoy the time lapse. Here you can see the skeletonized scale and how that's going to end up looking. It did reduce quite a bit of weight, so I'm pretty happy with how that turned out. Now it's time to also cut out the scales. It's a pretty simple process. Basically cut out the material, cut the tabs off, and grind them down. Here you can see the scales. They're pretty good, but they do have some gross sticker stuff on them as well as some weird marks. You can see how they go in the liner like this. I've done this once before with an older folder prototype and they did not fit together, so I went ahead and made 5 thou clearance, and that seemed to be an absolute perfect number because they fit in and they're a little snug, but they're not too hard to get out. I then went ahead and blasted the scales just to make things simple. And here you can see they look much better. They have a much cleaner surface and are way more uniform. So it's now time to press fit the little ball bearing into the scale to help hold the blade while it's closed. I just grab my arbor press and I put the little ball bearing in. Now when I do this, I over press it. This is the first time I've pressed a ball bearing into a blade for this specific reason. So I didn't know where to stop. The ball bearings I'm using are a little too small and I pressed it in too far, so it doesn't retain the blade very well. That's just something to learn in the future, and I will definitely dial in that process later, but for a prototype, it's okay. Here you can see the scales put together with a 3D printed blade. I haven't made the actual blade yet, but I wanted to do a quick test assembly. Like I said, I'm not a huge fan of this G10, and you will be seeing a much nicer color in the future. But everything goes together and seems to be working properly, so I'm going to go ahead and get working on the blade. Here you can see how the blade looks after the first operation. The bevel could definitely be cleaner, but like I said, for a prototype, it's not a big deal. Okay, we're going to be skipping ahead a little bit in the process. If you want to see the whole process of going from machining to heat treated and heat treating, then go ahead and watch this video. But I went ahead and skipped to post heat treat because that's where the most important things happen. So I'm going to go ahead and cut the blade out of the envelope and look at how everything went during heat treat. Here you can see how the blade looks out of heat treat. It is very clean. There's just a little bit of bluing up on the top of the blade, but other than that, it is very clean. It's now time to put it together and see how everything works. Now that everything is put together, we can go ahead and see how everything is functioning. It seems to be locking well and has a good flip out. There is no play or wiggle in the blade, which is good. That's exactly what you want in a bearing knife. And it's a very smooth operation and will drop close. I'm just fiddling around with the tightness to get it to the perfect tightness that bearings will be adjusted to. As you can see, the retention of the blade isn't great. It can definitely be shaken out, which is something I need to improve with that ball bearing, and so I'll go ahead and do that in the future. But overall, I'm pretty happy with how this is working, and it's definitely pretty good for a first prototype, and I'll definitely be refining this down in the future. You can see that the lock also locks over a little further than I'd like. I hand ground that angle in off camera, just because I kind of forgot I was recording a video, and so it doesn't go quite as well as I'd like. It does snap a tiny bit, and it really wants to go, but I think that the cutout in the blade doesn't let it drop far enough, and the ball bearing is just a little too small to make it practical, and so I'll definitely be adjusting that in future prototypes. I decided to go ahead and bead blast and acid wash the blade because I didn't like how it looked with the weird heat treat stuff, so I go ahead and do that. I then put the blade in ferric chloric acid. I go ahead and protect all the important dimensions like the bearing hole as well as the lock bar. And here you can see it coming out of the acid. Here you can see what the blade looks like after acid wash. The shiny stuff is oil on it, which you use right after an acid wash to keep it from etching further, as well as darkening the acid wash. It was pretty flat, and so I am going to go ahead and tumble it and give it a nice tumbled acid wash finish. The camera doesn't pick up the tumbled acid wash finish super well, but in person it looks really great. I already much prefer how this knife is looking with the acid wash blade. There's just one more step left, which is going to be sharpening the blade. I sharpen my blades on a belt grinder, and so I start with a 150 grit belt to establish the edge, and then I will move up in belt and eventually strop it. I then switch to a higher grit belt, in this case 400 grit, because that puts a finer edge on it. I don't need a mirror edge for what I'm doing, and I definitely prefer a toothier edge, so I don't go up in the 1000 grit belts in my general sharpening process. So I just go ahead, re-establish the edge with the 400 grit, and then I'll move to the stropping step. After I'm done with the 400 grit step, I go ahead and move to a leather strop belt. This just go ahead and quickly and efficiently takes off any burr that's left and puts kind of a final polish on the end. I do have some fine polishing compound on the belt, which is really hard to see, and that helps a lot with the honing of the edge. Here you can see just how sharp that edge got in the couple minutes I spent sharpening this from no edge at all. It is razor sharp and popping those hairs right off. A lot of the prototyping process is doing the design and finicking with weird things, and so I spent a lot more time behind the computer during this process than I did actually making the knife. I made the knife in about an afternoon, but I spent several hours designing and doing the CAD for this particular design. I'm pretty happy with how it turned out, especially for a first prototype, but this was a very brief video, trying to keep it around the 10-minute mark, and so there's a lot more that I can go into and that I will go into in the future about prototyping and some of the processes and stuff that I use for it. Here you can see the knife with the black G10 scales I said you see later in the video, and it looks way better, especially compared to the old scales. You may have noticed in this video we didn't make a spacer or a pocket clip. I kind of ran out of time on the video, and the 3D printed spacer works surprisingly well, but the pocket clip will need to be made later, and so I'll probably make an entire video going through my pocket clip designs and how I'm gonna end up making that. If you enjoyed the video, please consider liking and subscribing. Thanks for watching.